Hello, Algebra 1. Today we are talking about analyzing and interpreting inequalities. So let's go ahead and get started. We're going to begin with a review of what we were doing in our last lesson, so solving and graphing the following inequalities. This first one here, and actually the second one as well, we have variables on both sides. Again, we want to go ahead and move the smaller variable, which in this case would be negative 9x. So since it is a negative, I'm going to add it on over, and it will combine with our 3x. 3x plus 9x is 12x, minus 4 is greater than 12. And now that we have our x's together, we want to go ahead and get this x by itself. So we'll add our 4 to both sides. 12 plus 4 is 16. And then finally, we'll go ahead and divide by our 12. Notice we're not going to flip our symbol because we divided by a positive. And 16/12, both of those are divisible by 4, or you can go ahead and math frac this with your calculator, and we should get x is greater than 4/3. When we go ahead and graph this, we'll put our 0 and then our 4/3. 4/3 is positive. We should have an open dot, and our arrow is going to the right. All right, let's try another one. 11x and 7x. These variables are on two different sides, so now I need to move my smaller one, which is 7x. Since it's a positive, I will subtract it on both sides. 11x minus 7x is 4x. Bring down my plus 15. Okay, and then I'm trying to get x by itself, so I will subtract my 15 on both sides. 4 is greater than 4x. And again, we still need to get x by itself, so now I'll divide by 4 on both sides. 4 divided by 4 is 1. Since I divided by a positive, I am not flipping the symbol. However, in order to graph, we do want x to be first, so think again, we are flipping x in 1, and we will also have to flip our symbol, which means it will be a greater than, pointing to the right. So we have 0 and 1. Again, this is going to be an open dot because I don't have that equal to, and it will also be going to the right. So now we have some follow-up questions for these two problems underneath. We have, is x equals negative 2 a solution to the inequality? Well, negative 2 would be over here. We can see it's not on our arrow. Okay, and our reason is that negative 2 is not greater than 4/3. Okay, this is just a symbol that shows the slash through shows it's not equal to. So negative 2 is not greater, or excuse me, not greater than 4/3. Not equal to. All right, let's try this next one. Is x equals 1 a solution to this inequality? Well, 1 is right here. There's certainly the dot there, but notice it is an open dot. Okay, so 1 is not greater than 1. This is also a no. 1 is not greater than 1. We can also say it's not on our arrow. All right, what about this one? Is x equals negative 7 a solution to the inequality x is greater than negative 4? Well, what a lot of people like to do is draw a little picture here. So I'm going to graph this inequality. I'm going to put my negative 4 and my 0. And in this inequality, I'd have a open dot over my negative 4, and I'd be going to the right. Okay, so now I'll just take a look at this on my arrow. Negative 7 would be over here somewhere, which is not on my arrow, so this is a no. All right, what about the next one? This one here, if you want to graph it, you will need to solve it first. So let's go ahead, let's divide by negative 2 on both sides. And since we are dividing by a negative, what's going to happen? We will be flipping our symbol. Negative 10 divided by negative 2 is a positive 5. Be careful with that. Notice my symbol was going to the left, now it's going to the right. This is what you're going to go ahead and graph. Okay, put a 0, put a 5, and underneath that tells me it's an equal to, so I'm going to close in my dot, and again my arrow is going to the right. All right, so now let's take a look at what we're actually going to check. We're checking on x equals 10. Well, now that you have this graph, we can see, oh, well, 10 would be somewhere over here, and yes, that is on my arrow. So this is a solution. Now, sometimes you're lucky and those graphs are already there for you. So let's check these guys. Is x equals -1 a solution? Well, -1 would be somewhere right about here. We can see it is on the arrow. So this is a yes. And then is x equals 7 a solution? Be careful, open dot here. Since it's an open dot, this is a no. If this dot were closed in, then it would be a yes. All right, but it is open, so it is a no. All right, the last thing we're going to talk about today are some expressions that we might use in everyday language and what these actually mean in terms of inequalities. So if I say is less than, well, that's just a less than symbol, which again is pointed to the left for less than. If I say is greater than, well, that's just a greater than symbol, again pointed to the right. Is less than or equal to, well, again, that's just a less than with the equal to underneath. Greater than or equal to, again, pointing to the right, but we need that equal to underneath. Now, these next four are a little trickier. Is no more than. Okay, so for example, if I say you can have no more than 2 cookies after dinner, what I'm telling you is you could have 2 cookies or less. No more than means 2 cookies or less, which means this is really just a less than or equal to. So less than or equal to. Is no less than. So think about Great America. If I say, hey, you can be no less than 48 inches to go on this ride. No less than 48 inches. That means you have to be 48 inches or more. Right? 48 inches or more. So this is really a greater than or equal to. Okay, I'm going to write 48 inches or more. Okay, so that's why it's a greater than. At most. Okay, if I say we can fit at most 5 people in this car, at most 5 people. I'm not saying we can fit 20 people. I'm saying at most. The very most is 5. That's a less than or equal to. 5 or less people can fit in my car. Okay, and finally, at least. You need to get at least a 60% to pass this class. At least. At least means you need to get a 60 or higher, meaning greater than or equal to 60. All right, so now let's use this list up here to help us fill in these inequalities. X is at most 25. So go ahead, put your X and your 25. And again, at most means less than or equal to. Okay, you can have at most 25 cookies after dinner. It's probably a little much. Y is no less than -17. Okay, no less than, again, we can find our chart up here. No less than is a greater than or equal to help you, or think about a real situation and what the inequality symbol would mean in that situation. Like we were talking about cookies or people that fit in a car. Z is less than 0. Less than, make sure you point to the left. M is greater than or equal to 5. Greater than, make sure you're pointing to the right. Also have that equal to underneath. And then your 5. All right, a few more. Student council wants to raise at least 1,000 for prom. I'm going to put an S for student council and 1,000 for prom. And now let's think about what at least means. At least means we want $1,000 or more. So that would be a greater than or equal to. Here's my car problem. A car can hold up to 5 people. I'm going to put a C and a 5, up to. So in this situation, that means we can have 5 people or less. So this is a less than or equal to. Less than, pointing to the left. All right, to cancel school, we need more than 2 feet of snow on the ground. More than. Not more than or equal to, just more than. So I'm going to put an S for school or snow. More than is a greater than 2. Okay, and finally, you can borrow at most 4 books from the library. Well, what does at most mean? It means that 4 is the most you can get. So 4 books or less. That would be a less than or equal to. All right, so that's how we interpret inequalities. We can see a lot of these inequalities are actually having to do with expressions we use in our everyday lives. I hope you have a great day. Bye.